In this video, we'll learn how to create a smooth camera collision system. The camera will smoothly interpolate between colliding points instead of snapping back and forth. So here we are in the engine. I have a block out of a level, just a test level set up, and I have the character here. In this video, I have everything already set up, so I'll be going step by step through the functions I've implemented and see how it works. So I'm going to be using the controller to move the character around and the camera, so it's a bit smoother to look at. And you'll see, and the lines you see here right now are the debug lines, so you don't have to worry about this at the moment. We can get rid of them later. So as you can see, we have a camera attached to a spring arm, and the spring arm is positioned, in this case, on top of the character's head. You can see where the sphere trace is originating from. You can see here, like so. The spring arm's here. And while we're moving around, normally in a typical third-person template character, it would be jumping back into into this position, snapping out instantly, and then snapping in instantly. Because as you can see here, it's kind of smoothly interpolating. So just for a comparative reference, we'll try and see how it looks like in the default version, like this. So if I'm going through an area where there's like holes in it, normally this would happen. So it can be a bit jarring at times. Also like so. Yeah, so you might actually sometimes get lost where your characters are, where your character is. Let's go back. So first, for this system to work, we are going to have to go into the SpringArm component, and under camera collision, do collision test. We want to check it false. And then all we need to do is create one function to run on tick. And here, I just have it set up as a custom event. You can later on move this all into a separate function. But here, just for the sake of easier demonstration of the debugging and on stuff like that, I have it set up as a custom event that's running on tick. So we create a camera collision event, and here we want to do a sphere trace by channel. And from the starting point, we want to get the spring arm's world location, and for the endpoint, we're going to do a little bit more work than simply getting the camera's location. We'll get back to that in a minute. And for the radius, we just want to create a variable called probe radius and set a value to something sensible like 20, or you can change this to your preferences. And of course, the trace channel will be set to camera just to keep it more in line with the other collision matrix, with the other collision matrix items. And also, we want to ignore this character, right? We don't want it to collide with this character. So here, I'll just close this for a bit. Here we just want to make an actors to ignore array and then add a self-reference, which in this case would be the character blueprint you're working with. And here, for the sphere trace, we want to start obviously where the spring arm is. In this case, that would be here, the pivot point of the spring arm, the origin of the spring arm, and its relative position to the capture component. And that'll be the starting point. And to the end point, we want to get a direction. So basically, we're trying to get the red line here. So the red line, we're going to subtract the world location of the camera with the spring arm's world location, and then we're going to get a vector of it, we're going to normalize it. So what this does is we just get a directional vector. So we get a direction of that leads from the follow camera to the spring arm, I think, or if is it the other way? But yeah, I think it's from the follow camera to spring arm. And then after we get that direction, we multiply it. Since we have it normalized, we just have to create a set distance to it. So in this case, we're going to use a default spring arm length, and this is a variable I set on begin play. Don't worry about this. This is just a demonstration purpose function. I'm just going to move this around here. On begin play, next to the controller stuff and input stuff, we get the spring arm target length, and then set it to this variable default spring arm length. So whatever you set here, it's going to be setting this variable. And then this is going to be a distance. If you want this to be more different to your spring arm, you can just change it to a variable or switch it up into any variable to your need. But for this video, I have it set up as the spring arm's default starting length. And then I'll just turn off the debug here, and that's all you need to do for the sphere trace. And then we get the break hit result. You can get this by searching for break, like so. And then if it's blocking something, we want to get the location of the impact point. So for example, this is what's going on. This is where the sphere trace, let's just turn it back on, sorry. So here, you can see this red dot that just showed up, this red dot right here. You can see, this is the impact point. We want to get the location of that to use it later on for other variables we need to set or get. So obviously if it's hitting something, we wanted the camera to move in front of this pillar. Let's say if the character is here, we want the camera to set its position here, so we need to get the impact point here. We get that, and then we're going to adjust it by getting the distance. We're going to get the distance of the spring arm to the impact point. So here it'll be from this point to the impact point. That's the distance we're going to get. And then we're going to subtract it by the probe radius just to kind of pull it up front a little bit. This you might not need maybe, but I just have it so it's easy, so it prevents clipping to the wall in certain cases. And then this is the main part of the system. We're using the Interp2 node. So every tick, this is running every tick, right? So here, I'll just make this a bit bigger. Here, we're getting the current spring arm in this tick, and then we have the target length. This is going to be the target length, which, like I mentioned, is this distance. So we want the spring arm's target length as it is right now. We want to get it, and then we're going to set the target to where it's colliding to the wall. If it's set to a wall, to the wall. And then delta time, we're just going to use get world of delta seconds. This also, you can just search for get world delta seconds and you can get it here. And then we're going to have an interpolation speed. This is a custom function I created. I'll get back to it in a minute. And then we're going to return it. And then that return value will be setting the spring arm in this tick. And then we go back here, check again if it's colliding, and so on and so forth. And however, if there's nothing blocking, we want it to go back to its default length. For example, our baseline camera distance to the character is, I mean, the spring arm's length is 500, let's say. Then we want it to go back to 500, right? But we only wanted this exists here because we only want it to go if it's not the same. So we want this set happening not constantly. So if we basically, this works too, but the thing is, I just don't want this to be happening whenever the camera is not working. The camera collision isn't supposed to work. Just as an example, I'll just show here. So it does work basically. If you can see here, see, I'm colliding with nothing. The camera here, if you take a look, there's nothing colliding it, right? So it's constantly setting it. But the thing is, like, I just don't want to use any processing power or any kind of calculations here if obviously we're just going to keep it with the default spring arm length. So I just add a conditional branch check here, and with the same thing, all of this calculation can just be ignored, right? So this is just for that. And what we do here is check if the spring arm length is at its default length. If it's nearly equal, if we do nothing. So if it's not at its baseline target arm length, then we start setting it with the interpolation function we already have here. This is pretty much the same as this, except the target here is the default spring arm length, and here it's the impact point here. And then for the interp speed function here, it's a pure function I created. What we're doing here is getting the follow camera's location and the impact point, and then we're going to get the distance between those two, and then we're going to map range them and clamp them. So what, and we're going to get the value of these 2 points vectors distance, and we have a range A to B, an input range A to B, and an output range A to B. So in case some of you don't know what this does, if you just hover over it, the tooltip is pretty self-explanatory. Returns value mapped from one range into another, where the value is clamped to the input range. Example, 0.5 normalized from the range 0 to 1 to 0 to 50 would result in 25. So basically, if this, let's say this target arm length is, it's set to 0 right now. Let's say this is 500. And here it's 50, let's say it's 0. So 500 to 0 to 500, right? So if it's 400 and this is 0 to 1, then it'll be spitting here, it'll be spitting out a value of 0.4. Wait, 0, 500, and if it's 400 and this is 0 to 1, 0 to 500, 400, that's 80%, so it'll be spitting out 0.8 if I'm correct. It's a bit confusing, but basically I might have just said something weird, but basically all you have to worry about is just these tooltips. You get the input value, it sets a normalized range from A to B and then maps it to A to B on the output, and then it returns that to here. So what I'm trying to achieve here is I don't want the interp speed. I mean, basically you could just have it as a fixed value and it still works like so. If I just set it to, like, let's say just 5, you can see here it still works, right? Nothing wrong with this. But then this is just something I wanted to try implementing, because if the camera here, so this is an issue where the camera is trying to interpolate through the wall, and if this distance is too far, I wanted the camera to kind of pull in as quickly as possible so it doesn't stay inside this clipping state for too long. If it's a constant value, regardless of that, it might happen. But then if we have like a custom function here where it maps out the distance of the current camera to the impact point, we can map it into a certain in another output range. Then we can kind of create a system where if the distance is far, we have a faster interpolation speed. If the camera here, it's for example like this, these two distances, these 2 points distance is really small, so the interpolation speed would be okay still if it's smaller. So this part is just a function I created, but you can take a look at it, and if you can if you feel it unnecessary, then you can just basically use a constant value here or some other different value you want, and that's it. However, if you have a target offset in this system, it can cause an issue. So right now, as you can see, and especially it goes up here, it still has an issue. So there are just some issues I wanted to address, which is first the target offset. Let's go with this first. Here, if we set the target offset to 500, well, no, that's too much. 100. The thing is, it can come off in a, so basically the target offset isn't exactly the same as, where is it? The camera's world location. So even if you add a target offset here 100, it doesn't automatically add the target offset here, so you probably want to figure that out if you're trying to use a target offset. I think one method you could try is just kind of get the target offset here and then maybe add the variables here together, and then maybe it could work. Maybe I haven't tried that yet, but I think you could experiment with that. So that's one thing to consider. So if you follow this blueprint here, and if it's working not really as intended, maybe try checking if you have a target offset value set, and maybe try the method I just mentioned here. I think it might try to work. I didn't have much time to work on this more, so I haven't been able to figure it out yet. Hopefully, maybe if I have the time, I can come back to this, but I think as of now, it's just getting the SpringArm's target offset could work with that. And then the other issue here is right now, I don't have these objects here with any specific material function or anything, so okay, I'm just gonna get rid of the debug. It's getting a little visually disturbing, so distracting, I mean. So yeah, here, so you can still kind of see it clipping through, even though I have it in a way that if the distance to the impact point and the camera is big, it interpolates at a faster speed, like so. You can see that it still has to clip through it. And I think I mentioned in one of my previous videos, I did that with the character's material, with the dithering. But for in this case, I created a simple material for the world objects. It does change up things a little bit, so in terms of the art style in your game, you might want to figure out a way to use something like this, but this is just for you to get the idea. Even if it's clipping through, if I have a dither, which is like this, if it's very close to the camera, I have the material set so the camera, if the camera is close to those materials, it dithers them, like so. And here and here, so you can see it does provide a bit more visual clarity to the player if you have some sort of material function to help you with it. Of course, this system right now, as of now, it's not really perfect, obviously, but I would hope that it could help others, like anyone watching this, as a starting point to expand on their much cooler camera systems they're thinking of. Before we wrap up, I'll just show a simple. I think some people might just wonder what I did with the materials. Nothing fancy. I just get the world position and get the distance to the camera position. Then I remap it to value normalized range. It's like this node basically. Map range clamped, a version of material, and then input, start distance, end distance, and then I get the threshold. So because I wanted to normalize it from 0 to 1, right? And this alpha takes a value from 0 to 1, if my understanding is correct. So I need something to get from 0 to 1. And I got the distance, and if the distance is from 70, it returns a 0. 70 or below, it returns a 0. And if it's if it reaches 200, it spits out a result of 1, which will mean full dither. Oh, I meant the other way around, but yeah, you got the idea. So if you want, you can just copy this absolute world position. You can just search for this absolute, well, just world position works. You can get this node by searching for world position. You can get this by camera position. Oops, like this, like so. You can get this, you can just search off distance, search for remap value, and these are just parameters. You can just press 1, get a value here, right click, convert to parameter, name them something, and then and you can set it to a certain default value. And then if you create a material instance, you can change the value here. But material isn't the main part of this video, so that's just a quick look over it. And like always, I'm always looking forward to hearing any suggestions or feedback on my videos and my content. Thank you for watching the video. And yeah, I hope you all have a great day.